Tell you when I've started. All right. So these are the number of photos from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 from 10 males on Facebook that was presented to us yesterday. And we're going to analyze this data. They did a really good job of analyzing this data yesterday, but we'll take it just one little step further and talk about some terminology for today. So they made a histogram of this data, and their histogram looked. I'm gonna kind of roughly sketch it. They had a bar that height, and then these bars are by hundreds, half size, a gap, half size, a large gap here, and this was like 0 to 100, 200, 300, 400, 500, 600, and this one would be 1500. Okay, so what we should notice from this distribution, and I think this was at 3 or something like that. What we should notice from this distribution, its shape, and so we're going to call that shape skewed to the right or skewed to the higher or larger values, which means we have a lot of boys in the sample that had low numbers. There's something wrong with my scale here, sorry. We had a lot of boys with low numbers of photos on Facebook, and we had one boy that had a bunch. Not going to name any names. Okay? When our data looks like this, skewed, we don't want to talk about its center being the mean. So we're going to talk about, we did shape, center, we're going to talk about the median, because that's a better measure of center. Yes, sir?
What does that say? Skewed to the right hand.
Or skewed to the larger values. Because sometimes left and right won't make sense if you have your graph going in a different orientation. So we can talk about values here. The center we should use would be the median. So I can't pull that up real quickly here. So on your calculator, can you tell me what that median is? Why is it still doing that? Okay, maybe it's gone. Can you, from your calculator, tell me what that median is? 73? 273? So my median is 273 photos on Facebook. And I want to start not just giving out numbers. I want to describe numbers so that you still know what I'm talking about from this data set. Okay? Now, what is the lowest number of all those numbers? 94. What's the first quartile? 196? 195. You told me the median was 273. The third quartile? And the maximum was 1541? 1541. Okay. These 5 numbers that do come out in your calculator are called the 5-number summary. Okay. Now, when we are using the median as our center, we describe the spread as the IQR, and the IQR, what is that? Remember how you do it? Formula? And what is the spread of this data? Okay. So that means the middle 50% of my data, because if I'm going from Q1 to Q3, that's 50% of my data. 25 here represented from the min up to Q1, 25% represented from Q3 up to the maximum. So the middle 50% of my data has a length of 200 photos. Okay? So I report shape, I report center, and I report spread. And the other thing that I report when I'm basically describing my data set is outliers. Okay. Outliers is any piece of data or pieces of data that is far away from the pack. Yes, sir. Middle 50% has a length of 200 photos. When I talk about spread, I like to talk about distances or lengths. So your spread that you've been telling me for a couple of days, is some kind of a range, is not a very good measure of spread. We prefer IQR, which gives me a length, and standard deviation, which gives me an average distance from the center, which is, again, a distance, a length. Okay? So outliers are any data values far from the pack. So I got to look at both ends of my data for outliers. So let me go back and just look at my histogram. And I see that 1541 is very far away from the rest of the numbers. Okay? I see an outlier at the high values. I don't see an outlier that's far away from the low values. All right. So this I suspect is an outlier. We have an actual mathematical test for an outlier. So outliers can be defined as any value. So a value x of I is an outlier if x of I is greater than, you can just hold off while I'm doing the recordings. If x of I is greater than Q3 plus 1.5 times the IQR, or if x of I is less than Q1 minus 1.5 times the IQR. So let's test and see if that 1541 is actually an outlier. Yeah, I just had to get another piece of paper there. There we go. All right, my Q3 is, and it's going to be an outlier at the top, so I'm going to go from Q3 plus 1.5 IQRs. So Q3 is 395. Plus my IQR was 200 times 1.5. So that is 395 plus 300 is 695. So if your value is greater than 695 in this case, then your value is an outlier. Some people call that 695 a fence. So the 1541 is greater than 695. So the 1541 is officially an outlier. Okay, let's look for the lower fence for my outlier test. That would be the Q1 minus 1.5 times the IQR. Q1 was not 195. And from that, I'll subtract 200 times 1.5 and get negative 105. Did I do that right? Okay. So if any of my data values are less than negative 105, then that value is an outlier. Okay, so that's the lower fence and the upper fence in this data set. So I've got one outlier. So when describing this data, I describe it by its shape, skewed right, center, the median, spread, the IQR, and I note that the 1541 is an outlier. Okay. Now we make a little graph based on the 5-number summary and the outliers, and that graph is called a box plot, and it's a simple graph and it doesn't show us too much. Yes, sorry.
Do you have to check both ways?
So if you look at your graph and there's obviously nobody at all far away from the pack on the left-hand side, mostly because your numbers won't go below 0, then you don't have to check on the left or on the side where you don't think there are any outliers, but you just want to verify that something that looks like an outlier may be. Oh, do we have any other outliers in this data? Is the next highest value 674? Is 674 an outlier? My fence was at 695, so I only have one outlier, the 1541. So you may suspect when you're looking at your data that this one in the 600s, that's the problem. They start at 200, 300, 400, 500, 600. So you may have gone to look at this one and wondered, is this an outlier? And so then you look at your fence and you go, no, it's below the fence, so it is not an outlier. So we have one. Yes, sir?
So wait, you don't need to try both ways.
If it's obvious from your data that there's no outliers to the left, then you don't have to check it. But you want to check these ones that look like they're far away from the pack. And you want to make sure that you check that, yeah, this one is an outlier, and your check will also show you that this one is not an outlier.
Why does it matter that it is an outlier or not?
We're going to look at some data and decide what outliers might mean. Sometimes outliers, sometimes outliers are typos. So, that's one of the first things to check. Did I enter my data correctly? Sometimes outliers are special cases, and you need to decide, do they really belong with my data? Or is there some reason that maybe I shouldn't include them in my data? They're certainly part of the friends here on Facebook, but maybe for some reason I shouldn't use them in my analysis. So it's just trying to make a little decision like that on your data. Making sure you don't have incorrect data. That happens all the time. Put something in your calculator, put it in wrong. Okay, so we're going to make a simple graph that's going to show me my outliers and my my center, and it's going to show me my 5-number summary. So this is the box plot, or box and whiskers, they're sometimes called. And I need to set up a scale first. Before I make my box plot, let me set up a scale. My lowest value was 94. Guess I'll start at 0. My highest value was 1500, or 1541, so I'll put down 1600. So now let me put, right in the middle there is 800, so I'll put that there. I think I'll section this off 400 and 1200, and this is number of photos. And I think my scale is going to be okay there. There's the 2, there's the 6, there's the 1000, there's the 1400. Okay. So I start working from my 5-number summary. I guess I should start working from my outliers first. That's 1461. So that's 14. So that 1461, I'm going to mark with a little asterisk. And that's my only outlier. You mark all the outliers. This is called a modified box plot. You mark all the outliers with a little asterisk. And then I mark my minimum, which was 94, with a dot. What was the Q1? 195, so Q1 is going to be the side of a rectangle, the left side of a rectangle. What's my median? 273, so put it there. And my Q3, what's the Q3? Somebody look at their data so I don't have to roll back. 395. Okay, so that'll be the right side of my rectangle. And I make a little rectangle that has a little line going down the middle. And now I need to look at my largest value, my maximum, but my maximum was an outlier. So if your maximum is an outlier, you need to get the next value down. So what's the next biggest value? 674? Okay. So we'll mark that with a dot. And this is, I'm going to call this my new max because it's not the actual maximum in my data set, but it's the one I'm going to mark. And these dots get connected by lines to the middle of the box, making the right side and the left side, these little lines, are the whiskers. And then the rectangle in the middle is the box. And then what we see here is that 20 since I'm marking off quartiles here, 50% of my data is there's the first 50% is my minimum to my median. This other 50%, oops, goes all the way out to my outlier. Each part of the box here represents the middle, lower middle, and upper middle 1/4 of my values, of my numbers. These tails are also representing 1/4 of my data, but this tail has to include that outlier, so that 1/4 goes to there. And so if somebody asked me for the lower 1/4 of my data, I could say, well, it's going from 94 to whatever Q1 was, to 195 or something like that. So your box and whiskers and your 5-number summary start marking off fourths of your data and halves and 75% and 25%. And are real nice for visually just picking up your outliers here. So I'm going to go back through and I'm going to clean my graph up. Stop that. On a real box and whiskers, I wouldn't have all this red stuff. Okay. On my real box and whiskers, I wouldn't be marking this min, Q1, median, new max, outlier. This is what my real box and whiskers would look like. This box and whiskers is showing me that my data is very skewed right, because what is it, like 90% of my data is sitting over here on the left hand side, and then 10% is sitting way out here on the right. And the long length of this whisker also tells me a bit about my skewness. I might say this data was skewed even if I didn't see that outlier there. Okay, so there's your box and whiskers, there's your box plot, there's your 5-number summary, and your outlier test. I think that's enough. All right, let's see if I can get that processing here. Function 11. Function 11. I'll get it. Where's my function key? Function 11. There we go. I think that's it. Huh? Screen. Hey, hang on. Save changes. Cancel. I'll get this stupid thing stopped here in just a minute. Escape. Yeah, I can't get it to. Alright, while I'm trying to get the computer to stop, can you pass this up for me, please? Let me take a top one. Just take a few for your row and pass them back. Alright, come on, crazy computer. No issue. It's going to be classwork. Your homework is actually someplace else. Snag it. Where's my? There we go.